So now we will discuss about moment of inertia or product of inertia, three-dimensional coordinate with respect to three mutual perpendicular axes, plane or axes. Suppose these are mutual perpendicular axes. This is OX, OZ, OY. OX, OY are Z, three are mutual perpendicular axis plane, and P is a particle whose coordinates are X, Y, Z. P is a particle coordinate X, Y, Z. So OX, OY, and OZ are three mutual perpendicular planes or axes, and P, X, Y, Z is a particle in plane. In three-dimensional coordinate planes, this is P, X, Y, Z is a particle. X, Y, Z are perpendicular distance from OX, OY, OZ. Then moment of inertia of a body about OX means, what is the moment of inertia? Means mass and perpendicular distance from OX axis, means this one. Suppose if we draw here perpendicular, this is upside here. This is not in, this board is given in 2 dimensions, so we have to imagine in 3 dimensions. So this comes, suppose here in front of this board. So suppose the perpendicular distance is this one. Now we define this one is equal to this, and this is perpendicular like this one, and this is like this one perpendicular. Suppose P, and this is L, this is L. It means P m square is equal to P L square plus L m square. So from OX is summation m P m square. It means summation m Pm square means PL square, PL square plus Lm square. It means summation m y square plus z square. So moment of inertia about OX is y square plus z square. So this is PL. What is PL? PL is z, and what is this is y. Means this is z, this is y. This is x. So x square is equal to y square plus z square. It means x square is equal to y square plus z square. So this is x square means summation and x square. So this is y square. Similarly, moment of inertia of a body about OY axis. So OY axis means summation m x square plus z square. Moment of inertia of a body about z axis means summation m x square plus y square. So these are the moment of inertia in 3-dimension space with respect to OX, OY, and OZ. Now similarly we can find product of inertia of a body about OX axis. OX axis means OY and OZ plane. OY and OZ plane means summation m y z. The perpendicular distance from OY is y, perpendicular distance is here, and PI, similarly PI about of a body. This is an interested product of inertia about a body. So PI about OY OY means OX and OZ means summation M X Z and PI about OZ means summation M X Y means OX OY plane. So these are the product of inertias here about OX OY OZ or OY OZ plane, OX OZ plane and OX OY plane. So these are the product, moment of inertia and product of inertia in three-dimensional coordinates. Now we find moment of inertia and product of inertia some basic elements. So product and moment of inertia and product of inertia of some basic or primary elements. As we take some examples, how we get moment of inertia and product of inertia. So firstly, we have to find moment of inertia and product of inertia of a find MI and PI of a uniform rod of length 2A and mass M. Now we find moment of inertia. We will find moment of inertia of a uniform rod whose length is 2A and mass is M about, first is about a perpendicular line about a perpendicular line passes from center of gravity or middle point, passes from its middle point and perpendicular line which is passes from its middle point, and B is about perpendicular line which passes from one of its end or extremities from one end, if passes from one end and perpendicular to its length. Okay. And C, which is perpendicular to rod, perpendicular to this rod and passes from the same thing, perpendicular line passes from, or you can write perpendicular from rod, you can write like this one, and passes from this one end by making an angle alpha from the rod, making angle alpha from the rod. So we have to find perpendicular distance here of a rod. First, we have to find moment of inertia with perpendicular line which goes or passes from center of gravity or middle point, and the second is the perpendicular line passes from any one of end of this rod, and the third is the line passes from end of the point but making an angle alpha with the rod. Okay, so we have to find like this one. Suppose this is a rod suppose this is a rod AB and this is the middle point OL. OL is, this is the middle point OL. OL is perpendicular A. So suppose we solve A. AB is a line. So AB is a rod. AB is a rod of length 2A and mass M. And OL is a perpendicular line passes from middle point, passes from its middle point O. This is a rod here. This is length 2A. This is a rod of length 2A and this is middle point OA. So now first we have to find how we find moment of inertia. Mass of whole rod is 2A. M is the mass of whole. So let us suppose P and Q are points on rod with distance x and x plus dx from O. Means suppose here this is a point P and this is a point Q. The distance is, this is x and this is tail x. So this is x plus tail x. So PQ, distance between PQ is tail x. So distance between PQ is equal to tail x. This is tail x. Okay. So now mass of a particle of a body. What is mass of a particle? So whole mass divided by its length. Means whole mass is m. Mass of whole rod is capital M and divided by its length. This is a one particle, mass of one particle. So mass of here PQ. What is the mass of PQ? So mass of PQ. One particle is, mass of one particle is this one. If we have to find mass of PQ, it means we will multiply by this one element by PQ. Means m upon 2a. M upon 2a into PQ. PQ means del x. It means m upon 2a into del x. This is the mass. Now, what is the moment of inertia of PQ? Means mass into perpendicular distance square. So what is MI, moment of inertia of PQ from OL. OL is means mass m upon 2a into del x, mass of PQ into perpendicular distance square. What is perpendicular distance from PQ? This OL means x square. Perpendicular distance of PQ from OL is x square. So this is the moment of inertia of PQ. But we have to find moment of inertia of whole body. So moment of inertia MI of body means we have to integrate m upon 2a x square dx. And now what is the limit? This is here G, middle point. So this distance is here is A and this is A. This is A, this is A. So limit with x varies from minus A to A. So minus A to A. If we have to find moment of inertia about body about middle point, line passing through middle point and perpendicular to rod. So this is right. Now we have to only integrate m upon 2a x cube by 3 x cube by 3 minus a to a, or 2x cube by 3. This becomes 2a cube by 3, 2a cube by 3a, and means, and this is 2 also, so this m a square by 3. This is m a square by 3. So this is the moment of inertia of the rod about perpendicular line which passes from middle points. Now we come B. Second, moment of inertia. Suppose moment of inertia of a rod AB which about line perpendicular AM, which passes from one end and perpendicular to this rod. So this is same method this is the same method. We have to find now A. Suppose that P and Q are the same points, perpendicular distance is x and x plus dx. The same method, mass of PQ is equal to m upon 2a into mass of particle m upon 2a, mass of PQ, this is mass of a particle, is equal to m upon 2a, mass of PQ, this one, and moment of inertia of PQ, m upon 2a. PQ means del x, m upon 2a del x. What is PQ? Into moment of inertia is m r square, perpendicular distance is same, x square. This is just like first one, but only limit changes from, because this is the end point. So moment of inertia mi of a body integral m upon 2a x square dx. So what is the limit? Only limit. Here x changes. In previous question, x changes minus a to a, but here x changes 0 to 2a. 0 to 2a means 0 to 2a. So m upon 2a x cube by 3 0 to 2a means 8. 8 means 4 a square by 3. 4m a square by 3. If it perpendicular line about mi is about perpendicular line passes from any end of rods. So now in third, the same passes from one end, but making angle alpha from this rod. So perpendicular distance change now. Now perpendicular distance, suppose we draw here perpendicular here L. This is perpendicular. This is x. This is PQX, and perpendicular distance is here, this one. So in C, the moment of inertia of PQ about line making angle alpha from rod means m upon 2a PQ. This is same m upon 2a PQ, and perpendicular distance. What is perpendicular distance? PL square. PL square means m upon 2a m upon 2a. PQ means del x. What is PL square? PL square. What is PL upon x? PL upon x means AP. Wait, this is 90 degree, this is 90 degrees means hypotenuse, this is angle alpha, this is perpendicular, this is base, means perpendicular upon hypotenuse, means sine alpha. So PL x sine alpha means x sine alpha square. So MI of body, moment of inertia of body, is equal to integral m upon 2a x square sine square alpha dx, and the limit x varies from 0 to a. So x varies from 0 to 2a. So m upon 2a sine square alpha is taken outside, x cube by 3 means x cube by 3, 0 to 2a means 4m a square sine square alpha 3. So this is the moment of inertia about a line which makes angle, passes through one end of a rod and making angle alpha. Now we find product of inertia. Product of inertia about two perpendicular axes. Product of inertia about two perpendicular axes in same rod. Here, this is the same rod. This is OX, OY. This is X. This is Y axis, and this rod is A, and this is B. Now same method. The P is a point P and Q. This is del X and this is X. Perpendicular distance of PQ from OX is X and OY we have to find. So now moment of inertia. Particular product of inertia is PI of PQ. What is PI of PQ means? M upon 2A del X. M upon 2A is mass, summation M x y z, and perpendicular distance from OX and OY. Or you can say mass, summation mass into perpendicular distance from OX and OY. Mass into perpendicular. So mass of PQ is this one. And now this is perpendicular. So perpendicular here M upon 2A del X. So perpendicular distance from OY. Perpendicular distance from OY is X. This is X into perpendicular distance from OX. From OX to this PQ. This rod is considered as axis, and the perpendicular distance here is any distance. This is 0. So this is 0. So product of inertia of a rod about two perpendicular axes. You can consider the rod as an axis, then the product of inertia should be 0. So these are the basic properties. Product of or moment of inertia of a rod about a line which passes from center of gravity or middle point or one end, perpendicular line passes from one end, or making a line passes from one end but making angle alpha, or product of inertia. So in next video we will discuss more examples.